Massive waves tearing across the ocean at jetliner speed, tsunamis are nature's secret missile, born from deep underwater upheaval. On Unbelievably Science, we're decoding the shadowy mechanics behind these titanic walls of water. Why do they form? How do they stay hidden until it's almost too late? And what physics keeps them relentless? The mysteries aren't just about raw power, they're about invisible signals and shocking surprises lurking below the surface. Time to lift the veil on one of our planet's most formidable enigmas. Beneath the silent blue hush of the world's oceans lies a force so colossal, its origins have puzzled and fascinated scientists for centuries. A force unleashed not by the wind or tides, but by the restless motion of Earth itself. It begins far beneath our feet, at the tangled boundaries of tectonic plates. Here, tension mounts not over minutes or hours, but across decades and millennia, until suddenly, with a jolt faster than the blink of an eye, entire seafloors can shift upward by meters, a surge that displaces unimaginable tons of water in an instant. Picture this. In one seismic breath, an undersea earthquake radiates energy equivalent to thousands of Hiroshima bombs. But the oceanic response? Almost imperceptible on the open sea. No towering wave, no warning splash. Just a creeping bulge that passes ships without notice at jetliner speeds, masking its deadly promise. And yet, it's only when this hidden pulse approaches shallower waters that its true nature is revealed. The physics is astonishing. As water depth shrinks, the unseen wave transforms. Its speed slows from 800 kilometers per hour to a human sprint. But all that energy has nowhere to go but up, compressing into walls of water that can dwarf 10-story buildings. What many don't know, some tsunamis are triggered not just by earthquakes, but also by colossal landslides and erupting volcanoes. In 1958 in Alaska's Lituya Bay, a rockfall created a mega tsunami over 500 meters high, higher than any known building today, scarring cliffs and rewriting the local landscape in seconds. In rare twists of fate, atmospheric conditions themselves can generate meteotsunamis. A sudden drop in air pressure caused by fast-moving storms can, if aligned just right, push ocean water ashore in surges so swift they elude conventional tsunami detection systems. The science behind how tsunamis travel is layered in paradox. Each molecule of water barely moves sideways across the ocean, yet wave energy can cross entire hemispheres. After the 1960 Valdivia earthquake in Chile, the most powerful ever recorded, tsunami waves circled Earth several times over days, echoing power like ripples in a cosmic pond. Delving deeper into physics, we find soliton waves, unique, self-reinforcing solitary waves that maintain their shape across vast distances. Tsunamis often behave as solitons. Their energy doesn't dissipate like ordinary surf, but persists, undiluted by time or space. There are mysteries still unsolved. In 2011, after Japan's Tohoku earthquake, scientists discovered ghost tsunamis, waves detected only by distant sensors and never seen on shore. What creates these phantom pulses? Some theorize underwater topography reroutes energy in strange ways, causing echoes and amplifications no one expected. Consider tsunami earthquakes, a term reserved for quakes whose shaking feels minor but whose tsunami is devastatingly large. Their secret? Slow rupture speeds along shallow fault zones that move so gently they're almost stealthy, until their impact roars ashore with little warning. While global research races forward, indigenous Pacific Islanders have long read subtle clues. Animals fleeing inland, strange receding tides that expose coral reefs never seen before. Their oral histories warn generations, a living archive parallel to scientific data. Dramatically twisting fate is resonance. When tsunami waves and coastline contours synchronize perfectly, resulting surges can amplify dramatically. The shape of a particular bay or harbor might focus wave energy into a pinpointed catastrophe. A lesson learned from places like Hilo Bay in Hawaii. Cutting-edge technology now deploys deep ocean pressure sensors called DART buoys that detect minute water displacements across entire ocean basins. These buoys form the planet's earliest alarm network, yet even their reach is limited by oceanic vastness and unpredictable local effects. We rarely consider what lies beneath. The immense lenses and ridges on the ocean floor act like prisms and mirrors for tsunami energy. Waves can refract or reflect unexpectedly around islands and seamountains, producing multiple hits hours apart from a single seismic event. If you enjoyed these mind-blowing facts, hit like and subscribe for more unbelievable science every week.